Okay, I'm going to talk a little bit about 4.8, the last section in Chapter 4 of the pre-calculus textbook. Applications of trigonometry. In this case, you're finding the side of a right triangle in example 2 versus example 3 where you're finding the angle of elevation to a kite that has 65 feet of string out and is 30 feet off the ground. Let's start with example 1. I have an angle, and apparently I'm referencing its opposite and its adjacent. Opposite and adjacent tell me that I probably need to use tangent. Tangent of that angle, let me go ahead and just write it out. Tangent of an angle is equal to opposite over adjacent. So what I'm going to do is I'm going to fill some stuff in. Tangent of the angle, which is 57.2 degrees, equals the opposite, which is A, over the adjacent, which is not 125 degrees. That should be 125 feet. So 125 feet. Solving for A, 1 times A is just A. Cross multiplying gives me 125 times the tangent of 57.2 degrees. You would have to use your calculator, but hopefully it would come out to approximately 194. So A is about 194 feet. That was finding a side of a right triangle. Here we're trying to find an angle of a right triangle. Let me mark the right part, right angle. So apparently that's opposite and hypotenuse. What trig is opposite and hypotenuse? Opposite and hypotenuse, I think, is sine. Sine, SOHCAHTOA, opposite over hypotenuse. So the sine of what angle, theta, equals, what's the opposite? 30 feet, and what's hypotenuse? 65. So if I know that the sine of the angle is 30 over 65, how do I get rid of the sine? You do the inverse function of the arc sine. Oh, wait. You don't need to record this, do you? Because I just hit the wrong thing. Unless it lets me do this, which I doubt. Maybe it will. Okay, to get rid of the sine, you're going to have to take the arc sine. The sine and the arc sine will eliminate each other, and if you're in degree mode, you'll end up with degrees for your answer. If you punch this in, you get about 27.5 degrees for the angle theta. Again, you need your calculator to be able to do these. You're going to run into some problems in this assignment that deal with your bearings, such as north 40 degrees east. Please watch this. Do you agree that that's north? And then I go 40 degrees towards the east. Is that my angle? Can anybody tell me what this angle here would be? 50 degrees. But anyway, this would be the bearing or the direction. How about south 70 degrees east? You go south, right? And then go 70 degrees towards the east. Would that be over here? And this would be a reference angle of 20 degrees, right? It's a little tricky, the notation. Once you get used to it, it's not too bad. Okay, we're solving this triangle. This is problem 1 in your assignment on 4.8. We're doing 1 to 15 odds, 29 to 35 odds, 41, 43, 48. I'll try to do one in each group of problems. It says to solve the triangle. To solve the triangle, you need all three angles and all three sides. Usually they'll give you two things. Now, when it's marked with a right angle, you know that angle C is 90. Total degrees is 180 in a triangle, so I added 23 and 90 and subtracted that from 180 to get B to be about 66.5 degrees. Now, I need to find side A or side C. So, I don't know. We could label it. Perhaps that would make it a little easier. Do I know angle A is 23.5 degrees? Do I know side B is 10? And I know this angle B is 66.5 degrees up here. So, let's say I want to find A, and I'm going to use this angle. That's opposite, this is adjacent. That would be tangent. Tangent of theta is opposite over adjacent. So the tangent of what angle am I dealing with? 23.5 equals the opposite. What's opposite? The A that I'm looking for over the adjacent, which we know is 10. If I cross multiply, which you can do when fractions are equal to each other, 1 times A equals A, and this would be 10 times the tangent of 23.5 degrees. Punching this into our calculator, let's see what we get. Punching this into your calculator, it gives me about 4.348. 4.348. The instructions say to round the lengths to 2 decimal places. What's that 8 going to do? Round it up. So 4.35 is what A is going to equal. 4.35. At this point, we could use trig again, or we could even do Pythagorean theorem, right? We have two sides of a right triangle. We could find the third side, but let's practice a trig. Let's say now I'd like to use the C is what I have to find. That's the only thing I don't have. So the hypotenuse and adjacent, let's say. Which one is adjacent and hypotenuse? Would that be cosine? Cosine is adjacent over hypotenuse. So the cosine, what angle am I using? Am I still using this one? Okay, so the angle would be 23.5 degrees. The adjacent I know is 10, and I'm trying to find the hypotenuse. Cross multiplying gives me C times the cosine of 23.5 degrees, and that's going to equal 1 times 10, or 10. So opposite of multiplying is to divide, and so I'll punch this into my calculator. Punch this in on your calculator, you get 10.904, so I would round this to 10.90 to 2 decimal places. 10.90 if you like. Does it make sense that the largest side is opposite the largest angle? Is the smallest side opposite the smallest angle? I usually do that as a verification when I solve triangles. Okay, I'm going to look only at the top triangle first. X, I could break it up. It's the top two parts. Part of what I'm looking for is opposite, and I know adjacent. So what trig is opposite and adjacent? Tangent of 40 degrees will be opposite, which, what do you want me to call it, A? A over the adjacent 500. Cross multiplying when fractions are equal gives you 500 times the tangent of 40. Bear with me, I'll punch that into my calculator. So I punch this into my calculator, and so far I found out that this much of it, this much of x, which I'm calling A, is about 419.5, something like that. That's what this A is. Then I'm going to find B, and I'll add A and B together to get the length of x. Now, on B, I think I could look at, I'm trying to find the opposite and adjacent, so it's another tangent, I think. Tangent of 25 degrees is going to equal the opposite, B, over the adjacent 500. So when we cross multiply, we get B to equal 500 times the tangent of 25 degrees. Let me punch that in. 500 times the tangent of 25 degrees. 233 point something. 233.153. So this part down here, B, is 233.15, let's say. If I add them together, what would I get? Hopefully, to the nearest whole number, you'll get 653. Okay, you have the Statue of Liberty, and it's 305 feet tall. You have a ship out here in the ocean, and the angle of elevation to the top of the statue is 23.7 degrees. How far is the ship from the base of the statue? In other words, x. So I believe I would want what trig? That'd be adjacent and opposite. Adjacent and opposite kind of suggests to me to use tangent. Tangent of theta is equal to opposite over adjacent. So the tangent of 23.7 degrees equals the opposite, which I know to be 305. What I'm trying to find is the adjacent angle. So that's what I don't know. So I'll call it x, I guess. That's what I called it up in my picture. So if you were to cross multiply, you'd have x times the tangent of 23.7 degrees equals 1 times 305 is 305. Lastly, you're going to divide. So you have to divide by the tangent of 23.7 degrees. And when we punch this in, hopefully we're going to get, so you get 694.8. To the nearest mile or nearest unit, it would be 695 is the answer the textbook has. And what is this? This would be feet, right? Because everything's in terms of feet. So yes.